Good morning, students. Welcome to video lecturing class on dynamics of machines. In the last video, we have tried to solve the problems on balancing of rotating masses in different planes. So today we will continue with the problems, the same concept. So the next problem is, the statement is, a shaft carries 4 rotating masses A, B, C and D in this order along the axis. The mass A may be assumed to be concentrated at 160 mm radius and B at 180 mm, C at 200 mm, D at 120 mm radius. The masses B, C and D are 40, 30 and 50 kg respectively. The planes containing B and C are 300 mm apart. Angular spacings of C and D are 90 degree and 120 degree respectively with respect to B measured in the same direction. So the shaft and masses are to be in complete dynamic balance. Determine that first one, mass and angular position of A, second one, position of planes A and D. So before starting with this solution, first you should understand what are the given data. Okay. So here in the statement he has given that there are 4 rotating masses. There is a shaft which is containing 4 rotating masses A, B, C, D, and the order is same. That is, first mass will be A, B, C and D. The A mass A may be assumed to be concentrated at radius 160 mm. That is, radius of rotation for A is given, B, C and D is given. The masses B, C and D are 40, 30 and 50 kg respectively. Okay. And he has given the distance between the planes containing the masses B and C, and he has given angular spacings of C and D with respect to B. Okay. So for complete dynamic balance, you need to determine mass and angular position of A. And second is position of planes A and D. So let's start with the solution. So first you need to construct this tabular column. So here first the first column, it is plane, mass, radius, force, distance from reference plane and couple. So first you write up to this, that is force column, because he has given all the data A, B, C, D, and he has not given mass A, which you need to find out, and he has given radius of rotation. With the help of that you can calculate force. Here to write this column you need to draw this line diagram. So there is a shaft containing 4 rotating masses, and he has given the distance between planes B and C as 300 mm. Okay. So here I will take B as the reference plane. So distance between B and A denoted as X, distance between B and D as Y. After that you need to draw this space diagram. He has given B and C, angle between B and C is 90 degree and B and P is 210 degree, which he has given. Okay. After drawing this line diagram and a space diagram, you continue with this tabular column. So distance from reference plane B. So here I have taken reference plane B. So towards left side you have to take distance with negative sign, towards right side with positive sign. So towards left side it is mass A is towards left side of the reference plane. So minus X. For B it is 0, because on which your reference plane lies. And C is, he has given B and C distance is 300 mm, that is 0.3 meter, and distance between B and D is, that is from reference plane, is Y. So then you calculate this couple, it is this into this, you will get this one. Then you observe the force column and couple column, and you check out the angles which he has given. So here if you want to draw the couple polygon first. So there are two unknowns, and you know the angle between B to C and B to D, but you don't know the angle between A to B or A to C or A to D. So we cannot draw force polygon first. So instead of drawing force polygon first, we will draw couple polygon first. Because in previous problems, we used to draw for couple first, then force. But here, first we will try to draw this force polygon. So the first term, that is 0.16 MA, which is unknown, so skip that. 7.2 should be the magnitude, and for mass B, the angle is 0, that is along the horizontal plane. So draw a line of length 7.2. O to A length is 7.2 and angle is 0. Can take scale as 1:1. Then second is for mass C, it is 6, and he has given angle between B and C is 90 degree. Then you know the angle between B and C, that is 210 degree. So draw a line of length 6 in magnitude, angle as 210 degree, that is B to C. Then you join this C to O with a dotted line, that is with a straight line, to get the value of 0.16 MA. Okay, so from this force polygon, we'll get CO into scale should be equal to 0.16 MA. If you measure this distance and if you substitute here and if you substitute the scale, we'll get mass, that is in the plane AM. A is 22.5 kg, and also you will get the angle which is measured along in the counterclockwise direction is 235 degree. Okay, then you need to draw the couple polygon here. Once you know the mass and if you know this angle, so here again in this column also there are going to be two unknowns, but you have got the angle with respect to A. For mass A, you got the angle as 235 degree. So with the help of that angle, you can construct the couple polygon. So to construct that, so in this couple polygon, first you skip this because the total magnitude is unknown. It is 0, you cannot take this one. Then it is 1.8 is the couple for mass C, and the angle is 90 degree with respect to B. So draw a line of length 1.8 magnitude. So here I have taken scale as 2.5:1, and angle should be 90 degree, 0 to A. Then to complete this couple polygon, the remaining two values are unknown. Yes, this is unknown and this is unknown. No doubt you can substitute MA as how much you have got, 22.5, but still X is going to be unknown there. So but you know the angles for these two, that is angle with respect to B, what is A, and angle with respect to B, what is D. So by keeping your protractor at this point, draw a line of random length and which makes an angle 235 degree like this. Okay. Then from this point, draw a line of random length and which makes an angle 210 degree. This line. Wherever these two lines intersects, that point is going to be your B. Okay, so just keep your protractor at this point, downward direction, draw a line of random length, then angle should be 235 degree, and here keep your protractor again like this, then this angle should be 210 degree, like that you need to draw. Extend these two lines till they intersect, that point is going to be B. Measure this distance, that distance, that is O to B, is going to be your 6y, and A to B is going to be your minus 0.16 MA into X. Okay, so here from the couple polygon, AB into scale equal to 0.16 MA into X. From this we will get X as 1.039 meter. Similarly, OB into scale equal to 6Y and Y will be 0.413 meter. So here the only difference is, while for construction of this table and of drawing this phase and line diagram, before drawing the couple polygon, first you should draw force polygon here, because to get the angle for mass A, you need to draw this couple force polygon. Because in this tabular column, this is the only unknown. But if you are going to draw this one, there are two unknowns and only one angle is known. So that time it is very difficult to construct the couple polygon. So to avoid that, first you construct the force polygon, from which you will get mass A and angle with respect to A. Then moving further, next problem, a shaft running in bearings carries masses 20, 30, 40 kg in planes A, B, C with center of gravity from axis of shaft 30 mm, 20 mm and 15 mm respectively. The distances of planes B and C from A are 1000 mm and 2000 mm to the right of A, and relative angular positions of CZ of the unbalanced masses are such that they are in static balance. Find this to obtain complete dynamic balance. Suitable masses are introduced in planes D and E with CZ 100 mm from the axis D is 500 mm to the left of A and E 500 mm to the right of A. Determine the position and magnitude of balancing masses. So here there are three masses which are, or three bearings which are running on a shaft A, B, C. Okay, and for the dynamic balance, he has introduced two planes, that is D and E, and he has given their center of gravity, that is radius of rotation, as 100. He has given their positions. D is 500 mm to the left of A. A, B, C is the series. Left of A means D should come before A in your tabular column, and E is 500 mm to the right of C. A, B, C to the right of C means it should come at the end. So by reading the question statement carefully, you need to arrange this sequence. Okay. Otherwise, before constructing this table, first you construct this line diagram. First you draw A, B, C, and he has given the distance between AB and AC as 1 meter and 2 meter, that is 1000 mm and 2000 mm. And he has given that he has introduced two planes D and E. D is 500 mm towards left side of A, and C is 500 mm towards right side of EC. Okay, so now the sequence is D, A, B, L, E. You don't know the masses in reference plane, that is MD and ME are unknown, but you know the radius of rotation for all the masses. Calculate the forces, then distance from reference plane. So here I have taken this plane itself as the reference plane, that is D as the reference plane. So towards the right side you have to take positive, towards left side you have to take the distance as negative. So from D it is 0.5 for A, for B it is 1.5, for C it is 2.5, and for E it is 3 meter. Then calculate the couple. After that you have to construct this space diagram. So here none of the angles is not given. So take MA as the reference for which is acting along the horizontal plane. Accordingly you draw MD, MC and MD and ME. Okay. Then after construction of that table, here he has not given any angle, but to get the angle, he has given that the system is in static balance initially. So for this static balance, you can avoid the reference planes, that is balancing planes MD and M. Left with only these three terms. I have taken this A is acting along the horizontal plane. So draw first O to A as 0.6 as the magnitude. I have taken scale as 10:1. Then with the help of your compass, take 0.6 as radius, this A as center point, draw an arc. Then again 0.6 as radius, this O as center point, draw an arc. Wherever those two arcs intersects, that point is going to be your B. And you will get angle with respect to A for mass B, that is theta B you will get, and theta C you will get. Once you get these two angles, then go for the couple polygon construction. So for couple polygon construction, first it is 0, and here only unknown is going to be the last one, which is 0.3 ME. Okay. So for that, the taken scale as 5:1. So first draw a line from O to A, length is 0.3 mm, sorry 0.3 in magnitude. Okay. Then theta B, which you have got it from static force polygon. The length of line should be 0.9 and angle should be 120 degree. So that line is going to be A to B. Then from B, draw a line of length 1.5 in magnitude and angle as 240 degree. This angle also you got it from force polygon. Then join this C to O to complete the polygon. And whatever the distance between C to O or the length of this C to O should be equal to 0.3 ME, and angle with the reference plane, that is horizontal plane, is going to be theta E. So from this polygon, you get OC into scale should be equal to 0.3 times of ME. So when you substitute the length of this and scale, you will get ME as 3.471 kg and theta E as 31 degree with respect to MA. Once you get these masses and angles, then go for the force polygon, because in force column you have two unknowns. Okay, so now you have got only mass in reference plane E. Okay, so then only unknown is going to be this first one. Okay, so start with O to A as 0.6. So for this I have taken scale as 10:1. O to A as 0.6, angle is 0. Then A to B, the length is 0.6 and angle is 120 degree. Then B to C is 0.3 ME, which is equal to 3.471 kg and angle as 31 degree. Then D, that is from C, draw a line of length 0.6, that is 240 degree. Then join this D to O, it should be equal to 0.1 MD. So here one thing you can observe, first I have drawn O to E, then A to B I have taken 0.6. Then if you go with this tabular column, the next term I have to take this 0.6 with respect to mass C. But if you are going to take that C from here, your force polygon going to be end here only, because for static balance here, let's say you are going to end up with the same thing. So to avoid that, in such cases, whenever all the magnitude for three masses are equal, that time you skip that mass for time being, then take the next term. After that you can consider the same term. Okay, so here first I have drawn 0.6, then 0.6 with 120 degree, then directly I have gone to the force associated with reference plane E, that is 0.3 ME, and angle as 31 degree theta E. Then from here 240 degree and 0.6. Join this D to O to get the value of 0.1 times of MD. So now from force polygon, OD into scale equal to 0.1 MD. Therefore MD equal to 3.6 kg, and the theta D with respect to MA is 212 degree. It is measured in counterclockwise direction. So here, while constructing the force polygon and couple polygon, and while taking the data from this tabular column, be very careful that your polygon should not become complete in between. Okay, otherwise you won't get the answer. So here, as in this case, if I take that 0.6 here itself, your polygon is going to end here itself. Then what about the unknown quantities? So to avoid such cases, you can skip that one for time being. Then you can take that value for the completion of the polygons. Okay, so here the only difference is he has not given any of the angles. So to get the angle, and in the statement also he has mentioned that it is under static balance. For that reason, we have neglected the effect of reference planes B and E first. We consider the only static balance condition, and we have drawn this static force polygon to get the angle theta B and theta C. After that only we have drawn this couple polygon, then this force polygon. So we go through these two problems, try to solve these problems. Okay, so today we will end our session with this. If you have any doubt, you can leave the comment in the comment box. Thank you.